Welcome to the lecture series of digital electronics. Dear friend, today we will discuss the decoder. Decoder is a one type of MSI circuit, ICs are there, which is helpful to decode something. It is also popular in the combinational circuit design in microprocessor and decoding purpose. Discrete quantity of information are represented in digital system with binary codes. And binary code of n bit, binary code of n bit, this n bit binary code information capable of representing up to the 2 raised to n distinct element of coded information. So remember that thing. The definition of decoder is that a decoder is a combinational circuit that converts binary information from an input line to a maximum 2 raised to n distinct value or 2 raised to n unique output lines. If the n bit decoding information has a unused or don't care combination, the decoder output will have less than 2 raised to n outputs. Here, the circuit have a n input line and one enable line. Enable line enable the whole circuit. When enable IC, then whatever the n input lines corresponding input value particular output line is logic high, or particular line will become detected. Suppose how the different type of the ICs are possible. If I have a input line 2, so how many outputs are there? 2 raised to 2 equal to 4, and this called 2 to 4 decoder. Okay, suppose this is a one example. Second, suppose my decoder have a 3 input line, so 2 raised to 3 equal to 8 output lines are there, and it is called as a 3 to 8 decoder. And similarly, suppose my input lines are 4 in one IC, so as per the definition the output is 2 raised to 4 16. So it is called as a 4 to 16 decoder. Let's see how the decoder circuit look like and how it can work. So this is the decoder circuit where 3 input line. So output lines are 2 raised to 3 8. Okay, D0 to D7 is the output line. Now see, if my input is 0 0 0 x0 y0 z0, so all inverter output is 1, and here only the gate number 1 have a 1 1 1 input, remaining all gates have any one input is 0, so the result is this one is 1 and remaining all are 0. Okay, so 0 0 0, that time this output D0 will become 1. If my input is 0 0 1, then D1 will be logic 1. If my input is 0 1 0 XYZ, then only D2 gate is logic high, remaining all gates are 0. So in this combination, the D0 is 0, but D2 is 1. Why? Because the 0 1 0 input 0 1 0. So here the input is 1. So that means this will become 0 and this is 1. In this combination, only the D2 output is logic high. So in this way, the circuit is working and it is called as a decoder. In decoder, normally the AND gates are there and each AND gate have a logic equivalent to the Minterms, which is represented. So whatever the binary information, particular line is enabled. Okay, how can we use that things practically? Practically, very easy. It is very useful in some way there. Understood that thing. Suppose, let me give one example how the practically it is useful. Here, I have one master card, and according to it, the particular door. Suppose understood that these are the doors are there. Different doors are there. If my input card is 011, so 011 according to that means 1 4 2 1. If this is equal to 3 in decimal. So third number door will be open only. This will become on. Okay. So in this way, we can use also as a, suppose I have a 8 lockers. 8 lockers are there, and every locker have a individual card to open it. So 8 different cards are there. According to it, whenever the particular card is pressed, suppose here the 111, the card information, so 8 number, the D7 will become on, remaining all are off. Okay, suppose the input is 111. At that time, so this will become 0 and the 1, 0 and 1. So only D7 will be occur if the input is 111, and particular this locker will be open, remaining locker cannot be opened by this card because this card chip information is 111. This is the simple example. Normally 16 to 14 bit input decoders are used in this type of the application. Let's see the truth table of this function. If my input is 000, then D0 is 1, remaining all are 0. 001 means 1, so D1 line will become enable. D2 is 011, 010, this is equal to the 2, so D2 line will become 1, remaining all are 0. Similarly, 011 is equivalent to binary 3, so third line will become 1. 100 is equivalent to the 4 in decimal, so the fourth line will become 1. 101 means the fifth line is enabled. 110 is the sixth line is enabled, and 111 is 7 line is enabled. Okay, so this is the symbol. Remember that thing, symbol of decoder. So from this symbol we can say that 1, 2 and 3, so 3 input line, 2 raised to 3, 8 output line. This bubble so that invert input. Okay, so if there is a bubble, we can say that this is 0 and remaining all are 1. So it is called as a invert output. Invert output. Enable is also bubble. Bubble means when E equal to 0, it is enable. And if E equal to 1, then circuit is disable. It is not work. So bubble meaning ये होता है कि अगर E equal to 0 है तभी ये enable होगा. If E equal to 1, the circuit does not work. And if my input is 0, 0, 0, then D0 will become 0 and remaining all are 1 because the outputs are inverted output. Inverted output as per the symbol. Now here question is occurred, how this decoder is useful in practically this MSI circuit. As I already given the example of different lockers can be opened by particular card. Let's take, suppose here the one statement is given, we have to design full adder circuit with a decoder and 2 OR gate. So let's see how the full adder circuit, combinational circuit have a truth table. So we know that the some have a minterms 1 2 4 7 and carry have a minterm 3 5 6 7. This is the carry output, this is the sum output. So decoder I have, where which decoder is required. First question is that which decoder is required. So it is depends on number of input. How many inputs are there? So inputs are three inputs are there. So 3 2 raised to 3 is equal to 8. So that means 3 to 8 decoder is required. Okay. Now XYZ input and D0 to D7 output. Some have a 1 2 4 7. 1 2 4 and 7. These four minterms are there. So these four minterms are ORing and generate the sum output. Which one? Okay, 1 2 4 and 7. Okay, 4 and 7. This will be noted. While carry have output 3, 5, 6 and 7. 7 is in everywhere in the both the circuit. So this minterms ORing, so it can give the sum of product of 3, 5, 6, 7. Okay, so this circuit is work like as a full adder, where we have a 3 to 8 decoder, 1 and 2 OR gates. Gate number 1 for sum and gate number 2 for carry out. Means we can design any circuit with the help of decoder if we have a minterms, then we can design. How? So one is decoder is required and OR gate is required. So some of particular input, it is called as a minterms. These minterms we can add and we can make the circuit if the expression is in sum of product. Okay, let's see, take one example. Suppose the here one another thing is that we have to design. Suppose I require the circuit my input in sum of product term A B C D. Four inputs are there, but I have an IC which is 3 to 8 decoder. But here which decoder is required? Four inputs, so 4 to 16 decoder is required. So how can I use, or how can I use this MSI 3 to 8 decoder in particular application of 4 to 16? So 3 to 8 decoder require 1 into. Okay. So first decoder, that is a 3 input, we both have a 3 input, X, Y, Z. Here also X, Y, Z. But we know that there is one enable line is there. So what we will do, the fourth input connected with enable line. Okay, and if W is 1, then this will become 0, and so second decoder is useful. But if W value is changed, if W is 0, then this one and below enable disable, this will become gate number decoder number 1 will be enabled. Okay, and both have a D0 to D7, so for this one will become lower minterms, because it is 0 when W is 0, so 0 and XYZ is 0 0 0 to 1 1 1, so that means 0 to 7. Okay, but when W is equal to 1 and XYZ is 0 0 0 to 1 1 1, so if I put here WXYZ 1 0 0, this will become 8, and 1 1 1 1, all four are 1 means it is 15. So D8 to D15 work like as a output of the second gate. So in this way, the two decoder can expand as a higher size of input decoder. So in this way, we can design 4 to 16 decoder with the help of 232 decoder. Again, remember that thing, dear friends, the decoder method can be used to import any combinational circuit. However, the implementation must be compared with all other possible implementation to determine the best solution. In some case, this method may provide the best implementation, especially if the combinational circuit has a many output and if each output function is expressed with a small number of minterms. At that time, this decoder will be very useful for the designing if the expression is in terms of sum of product. And decoder is many times useful, not only that much. It is also useful for the like as a Antakshari butter design, or sometimes it is useful for the application like as a door, multiple door opening, or in address line selection in microprocessor. So there is a multiple application of decoder, and decoder IC ready-mades are available. Like as a BCD to decimal decoder is 7442. But in this way, it is very useful. So here I conclude the decoder. I hope is it making sense to everybody how to useful a decoder in digital circuit design.